to our Open Science Cafe networking event today. It's great to see so many open science enthusiasts today. I'm happy to host Kaveh Bazargan from River Valley Technology and Mark Hahnel from Figshare. We are at the ICRA conference this week not only to promote our journal portfolio, but also to promote open science, because it's in the core of our mission and vision of our journals. So we chose the topic of open data today for a little discussion, because it's a trending topic, it's an important topic, and we want to bring it closer to a wider community of researchers, particularly in AI and robotics. So in your view, what is the benefit of publishing open data in support of the research that authors are putting out there?
I think it's very hard to argue against open data. They say any science is actually open science. What's the point of doing science if people can't see what you've done? I can go back to the days when I did research, when I was a physicist. I wrote a few papers, and of course we published a paper, they've been cited, but where's the data? Where is the actual pieces that I referred to? I don't know, and I wish they were. This is many years ago, and I wish that data was available so someone else can reuse it, can check it, and can build on it. So I think there's not much to really add to that. I feel it has to be open. Don't you think?
I think there's like the cultural problem and the actual technological problem of how we've moved along over the last few years, and this whole idea of open science is just science done good, right? Back 300 years ago, when researchers started publishing in academic journals, it was a way of disseminating the content. Not everybody had a printing press, so they'd send it and they'd send it out. It was open. And so if you invented that today, it would be just publish all of your research outputs that back up your findings. And we still have the paper today, because the paper is the context. You know, you publish an IntechOpen, you've got the context, the journal there, but you want to have the transparency, the reproducibility, you want to build on what's gone before. And so now we have the technology that allows us to do these things, and so excited to be working with IntechOpen at Figshare. But it allows researchers to just publish all of the research outputs that back up that paper, and the whole community in general. I think this is why funders have really pushed for it, have said this is the biggest return on investment we can have right now, with a lot of low-hanging fruit already taken. So I think it is a no-brainer. I think it's just been a cultural, we didn't have the technology, now we have the technology, and now we have to pull up the culture change of legacy publishing, right, which relied on more traditional ways of publishing research in the past.
And make the most of it. I really think we're on the right path, because when IntechOpen started working, we are natively open access. So for us, transitioning to open science was natural. But I remember open access was, I won't say extreme, but it was something new, and we had to do a lot of education of authors, explaining what it is, what are the benefits. And today it's been 10, 20 years, and open access is mainstream, and I believe for the open science movement that is going to happen even faster. At least that's what I'm hoping for.
Yeah, more publications last year were published open access than closed access. It seems, I'm sure we'll never get to 100% for certain reasons, but I'm sure we'll get to 95%. And that whole idea of, if we paid for your research, it should be open to everybody. It's that training of researchers who, when I was a researcher, I didn't know that my university was paying for access to content. I just thought it was free. And so having it transparent, the financial models as well, I think makes a lot more sense for academia moving forward as well. Open science, open research, they seem to be where we're headed.
Yeah, I can't argue with any of that, Mark.
And since we are at the Robotics Conference, what are your thoughts on how can open science and open data particularly positively impact faster research, discoverability and just progress in general?
It really, going back to what I said, that if I were to read some research and trying to build on that, I don't want to have to guess and dig and try and second guess what those researchers did. I want to take that data and build on that immediately. So that's going to save time for me to do my research. As I say, it's almost really obvious that it has to be open. There are, of course, cases where because of privacy issues, medical data, they cannot be open. But even there, what we need to do is to make sure that it's as open as possible by anonymizing the data and making sure that, again, medical research can progress as fast as possible. It's a no-brainer, I would have thought.
And I think some fields lend themselves to this kind of new way of working a lot better, and particularly with robotics and new technology. Everybody is generating data, right? It is the files that you create when you do your research. Everything's becoming more computational. But when you look at how computational, robotics is really up there at the top, along with things like genomics that you can see an obvious return on investment for. And I think one thing we found that's really interesting is sharing software, sharing snippets of code. What are the algorithms you're running? In terms of incentivizing researchers to do it, one of the things we like to say is you can get credit for all of your research outputs. You can have more impact. We know that sharing data is associated with a 25% increase in citations to the paper. So there's that immediate benefit. But we also see, particularly in engineering and physics and computer science, by sharing your code, researchers who write code natively tend to describe it very well because they want it to be reused. So we often see that the files that have more impact, that have more citations, are snippets of software, are lines of code. And I think that lends itself very well to the robotics space we're in.
Yes, and speaking to the exhibitors from the industry and from academia here at the conference, there is a strong network of open source supporters, and they've argued that open source has done so much for the development of robotics, and it just can be seen, it's just visible. So I don't know, in 2016 when we went to conferences like this, the exhibition was, I won't say far less impressive, but you can see obvious development in a time span that is shorter than 10 years. And now with the rise of open data, I think that in 2 years we're going to have a completely different exhibition, and in 2 more an even better one. So I think for these fields specifically, it's very beneficial, and as I said, you can see visible progress from year to year, and with support of open data, I just think it's going to be faster and better.
Absolutely. And I think we should make sure that Mark, in passing, mentioned getting credit for researchers. I think that the institutions, funders, publishers can, if researchers know that they get more credit for opening their data and making it reusable according to the FAIR principles, then that will encourage them too. Because they may think that, well, if I give my data, someone else might trump me, something like that. It's actually the opposite, that giving your data helps other people. So in whatever way, we should make sure that they get credit for that too.
And I think with that, we have to, this whole idea of if academic publishing was invented today, it would look like X. And that may be true, but we have to adhere to the old cultural norms of, this is how you get promotion, this is how you get tenure, and we have to apply the modern ways of working back into that. So you mentioned software. A lot of researchers will publish their research on GitHub, and a lot of open source code is on GitHub. And if you're applying for a job at Facebook, your CV might be your GitHub repository, and you say, cool, there's my credit, you can see what I've done. But that doesn't lend itself into, the traditional funding workflows. You need persistent research. You need that data, the code to always persist so that when people cite it, which is one of the metrics with which we monitor impact, you'll be able to make sure that that data or that code is always going to be around. So that's where we're starting to, the cultural meets the technological midpoint, and I think it's come a long way in those 10 years, as you say. This whole space has come a long way in those 10 years.
It's come a long way already. On that note, what's next for open data? What can we hope for? How will it become better? How will it become more open? What are your views?
For me, I think that the last 10 years have been all about encouraging researchers to put their files on the internet. Put your data on the web. That's step one. And then for the next 10 years, we want to be looking at how can we make that data useful. If you said to me 10 years ago, this whole idea of moving further faster with research by building on top of the data would be having serious effects, I'd be questioning how impactful that could be within a short time frame. But we see with DeepMind, the company that Google owns, the AI company, they've basically solved protein folding using AI and well-described data sets from Protein Data Bank. So I think the next step is making the data that we have well-described, better metadata, so that we can feed it to the machines and they can do a lot of the heavy lifting for us, so that it's like chess. Humans and machines together will beat the machines and will beat the humans. So we need to apply that to academic research, and the way to do that is get open access content into the machines, open data into the machines in a way that they can understand, findable, accessible, interoperable, reusable, and then have that used as the baseline for paradigm shifts in research. So that's what I'm excited about.
I would add, I think you've said it, but one of the things is make your data open, but ensure that it is in an open standard too. Because if I have I won't name names, but if you have a proprietary spreadsheet, for example, if that the software that runs that is in 15 years' time, if it's not there anymore, you can't read that data. So we need, just as with articles, we need to have standard XML that we've all agreed on, JATS XML, for example, that we are not dependent. So we need to get rid of dependency on any non-open or proprietary software to read that data and build on that data.
I think that's a really interesting point, because things like JATS XML, you're not necessarily asking the researchers to send in their JATS XML, but there's ways in which the publishers can have another value add in preparing the content in the right format. And I think the big thing with data on that side of things is the education level, because a lot of researchers, they're new to it. And so we do this thing called the State of Open Data every year, where we survey researchers to see what their thoughts are. They all used to be big fans of open science until they realized they had to do stuff now. And they're like, oh, I've got to do some more work now? Oh yeah, I'm busy already. But one of the things you find is a lot of researchers don't know much about licenses of research data or file formats. And when we ask who do you go to for help, 38% go to their university, 40% said they go to publishers, because they see the publishers as the dissemination point. And so I think there's a big role to play in the education of researchers, which I guess is the kind of thing we're doing today.
Yes, I completely agree. We are on board with that. Just this year we started a series of webinars discussing open science topics. So you were our guest in the last one. The next one is actually, the topic is open data. So yeah, I'm taking this opportunity to invite everybody to attend the webinar. It's going to be online and free. So yes, join us and learn more.